Alright, so today I'm going to be explaining another important article with the title ABDPool, Attention-Based Differentiable Pooling. This ICPR paper in 2022. Graph neural networks have achieved state-of-the-art performance in a wide range of graph-based tasks such as graph classification and node classification. This is because the unique structure of GNNs allows them to effectively learn embeddings for unstructured data. One important operation for graph classification tasks is downsampling or pooling, which obtains graph representations from node representations. However, most GNNs are associated with global pooling that cannot learn hierarchical graph representations. Meanwhile, current hierarchical pooling methods have the shortcomings of unclear node assignment and uniform aggregation. To overcome these drawbacks, we propose an attention-based differentiable pooling operation in this paper, which can learn a hard cluster assignment for nodes and aggregate nodes in each cluster differently by introducing an attention mechanism. So you know that diffpool has a high computational complexity, and even for this assignment matrix you need a GNN. So the ABDPool at layer L refers to convolution. We generate hard assignment matrix. I think even the previous video was about hard assignment. And then we have select nodes for each cluster. Finally, we generate attention matrix for each cluster. This module realizes node differentiated aggregation in each cluster. For each cluster, the teeth cluster, the nodes aggregation equations are the softmax of query keys, and then we finally update the adjacency matrix using this attention that we have, which is obtained here. So we concatenate all of these ASZ. And once we have some adjacency, if you have an adjacency, the matrix, the next layer can be updated easily using these H and S. So this is an illustration of our proposed method. In every pool layer, the input graph features are transformed into a coarsened graph by convolution. Node assignment and attention-based embedding aggregation. So as I said, we have hard clustering. There is no intersection between clusters. We know for 100% which node belongs to which cluster. And then here we use this interesting idea, attention-based aggregation. So this figure, as you see here, it shows each ABD pool layer processes the input graph into a coarsened graph through the above steps. And we use different colors to describe the node features. So we have different node features, different colors, and so in the convolution process, the embedding feature after a convolution network is denoted by a deepening color. Then, assuming that all nodes are assigned to two clusters, pie charts denote the hard assignment of the embedding. Lastly, the attention mechanism is applied to aggregate embedding in each cluster to generate a coarsened input graph. So, the add attention mechanism to aggregate nodes, when we add, so it has some improvements on the basis of diffpool. So ABDPool has these improvements. We have learning hard cluster assignment, also adding attention mechanism to aggregate nodes. And these are very popular data sets for graph classification. If you look at ICML papers, NeurIPS and ICLR, each paper pairs, they use these as data sets for graph classification. And as you see, most of them have two classes. There are other data sets like NCI1, MuTag. Oh, MuTag is here. And so the result is this. They also compare it with the kernel methods. And their methods, this one, has improvement for example, MuTag. For MuTag, diffpool gives 80%, so adding attention gives 10% more. Adding hard clustering, they showed that it creates 10% better accuracy. Of course, we have this standard deviation that if this one is too big, then it is mixed, so it's in the noise. You cannot differentiate two things. You cannot easily compare them. That's why you go to other things such as time complexity, computational complexity.